Good afternoon, everybody. I'm going to do my customary waiting around to see, to see and make sure that everything actually looks good on y'all's end. Especially, there we go, because the streaming software I use has started doing this thing where I can't open it, so I have to reinstall it every time, and it keeps my settings, which is good, but also I have to reinstall it every time. Anyway, I'll figure it out later. I always forget about it until it's time to stream, and then I'm like, ah! Today, we are continuing my series of NLP sort of stuff. So last week, if you joined me, we did... so we did a discussion of how to turn words into math, basically. And today we're going to be doing that process for ourselves. So I have written this notebook, which is public, which is not public. Never mind, I will make it public before the end. And I did a little bit of, work ahead of time, and I should... I thought I gave myself edit access. I guess I didn't. I only gave myself viewing access, which means that I can fork it. So I'm gonna fork it. And I did a little preparation, which I don't usually do for these streams, just because I didn't want to be Googling things to give you guys links the whole time. So this is some information that might be helpful for you. So like we mentioned last time, tokenization is the process of taking in unstructured text, quote unquote unstructured text. No human language is ever completely unstructured. We had this talk last time. And chunking it into chunks that are relevant for you and your task, whatever that is. So usually it's something like words, and it can also be things like syllables, characters. That might seem trivial, but if you've spent a lot of time working with Unicode and joining characters, you know that in fact character level segmentation is not trivial at all. Syllables, if you're working with a language that uses a syllabary, that might be useful for you. Sentences, that's what Punct does. So any sort of process of taking in a text stream and then chopping it up into little bits, and then you can put those into, any sort of data structure. If you care about order, you can use, something like an array or a vector or something that's going to maintain information on order, or you can throw it into a hash data structure if you don't care about order and you're doing something like building a lexicon and all you're really interested in is how often different words occur. So it's really going to, sorry, I dropped something. It's really going to depend on the specific task that you're doing, what level you want to tokenize at. And there's a bunch of different tokenizers. The ones that I have run across most frequently, the algorithms behind them, they are mostly rule-based. So somebody sits down and decides, this word is actually two words. So like it's with an apostrophe. You might tokenize that as two words. It is because it's a contraction. And that requires, human labor. So you don't usually want to build your own tokenizer unless you're working on a very low resource language and you got to do it. If you're working on English, you don't have to. So the Penn Treebank tokenizer is probably the most, is that really a URL that's going to work? Oh, it is. So it's very small. Let me zoom in. The Penn Treebank, if you're not familiar, is a data set of parsed sentences, hence trees. So they've been parsed into this tree data structure. From a variety of sources, usually mostly formal written text, so like Wall Street Journal sort of thing. And these are the rules that they use. So punctuation is split from the adjoining word. So children's is turned into 3 tokens, children, apostrophe, and S. Double quotes are changed to single forward and backward quotes, so like this. And if you're wondering why it's like that, that's much more easy to parse with something like LaTeX. Contractions and genitive nouns are split into component morphemes, and each morpheme is tagged separately. So some examples here. So this is won't, would not. It's been contracted. And they're not sort of like done back to their original word. So you would be able to say all the times that won't occurs, all the times that woe occurs, all the times that n't occurs. And then they have specific rules for hyphens, dashes, ellipses, etc. And then they also have information on the way that you're supposed to deal with acronyms. So anyway, this is a set of rules that have been hand-built based on the language. So languages that don't have contractions, of course, this isn't going to be a thing. And that's sort of the algorithm that's used by things that are based on the Penn Treebank Tokenizer or the Penn Treebank style. You'll see that sometimes. The Punkt Tokenizer is sentence level tokenization. So you would put in your text stream and you'd get out sentences. And it's based on Kiss and Strunk 2006, which is an ACL paper. And if you really care, you can go read that, but I'm not going to do it on stream. And then the Moses Tokenizer is part of the, that's not how you spell that, Moses Statistical Machine Translation Project, I guess you'd say. And they have pretty strict requirements about what your input data is going to look like and your output data to train and to do like updating an existing model. So if you're working with Moses, you're probably going to want to use the Moses Tokenizer. And all of these tokenizers, again, are for English. Moses might have multilingual support. And they all have different implementations. So if you can only use one tokenizer ever, hi, João, I'm guessing? It looks like Portuguese. If you can only pick one tokenizer, I would recommend NLTK. It is a little bit fiddly. There's a lot going on in this module, but it's very, very flexible. So it's one interface that will let you work with a lot of different algorithms. NLTK is the standard for research. Oh, I don't actually need to highlight token. Nope, I don't actually want to reload. No, it's, well, I did it anyway. So it's got a lot of tokenizers in it, and we're gonna work with this. My plan is to go through and do NLTK, Spacey, maybe core NLP, that's sort of like if we get through with the R stuff, and then tokenizers, and then a little bit with tidy text. So these two are in Python, and these two are in R. So I do want to do both languages. We've got a lot on the docket today. But that's sort of the general idea. And like I said, NLTK has access to Penn Treebank and Punkt and Moses, and some other ones that I don't see used as often. And that the fact that I don't see them used does not mean they're not good. It just means it doesn't, like, my circle of friends aren't chit-chatting about it, and that it's not a reflection on the quality of the tokenizer. And you do, if you are writing a paper about your results, you do definitely want to say which tokenizer you used, and ideally you're going to share your pre-processing code, because which tokenizer you use is going to have a big effect downstream when you're doing things like picking a parser, or like if you're just counting number of words, right? If you count won't as one word, then that's going to show up fewer times than N''T, because N''T is going to show up in can't and shouldn't and shan't and, you know, all those words. So it's pretty important, and you can't replicate work if you don't know what tool chain they were using. So we are starting off in Python, and I actually haven't given myself a corpus. So let's add a corpus real quick. I think we have, linguistics is going to be the tag that has a lot of the corpus stuff under, because that's what I put all my corpora under, and I uploaded a lot of corpora at various points. This is speech. I'm more interested in text. Sentiment labeled sentences data set. Can I open this in a new tab? Can I not open this in a new tab? Oh, interesting. I feel like I want to be able to click here and open the data set in a new tab. That should be a bug report. yeah, let's just add this and see what it looks like. So I just want a data set to be able to, if I had done more preparation, I would have picked my data set to be able to go through and label. So it looks like we've got a zipped file with some text in it, and it's going to be by sentence. And it looks like we've got Yelp, IMDb, and Amazon sells. So let's take a look. We can't see that. So let's take a look at reading in some of these files. And we need to read it into the NLTK. So let's just look up how to do that. Read text file. And each of the, there we go. Each of the different libraries is going to look slightly different. And they're going to use slightly different internal data structures. There's not like, this is the standard data structure that we all use for NLP for all our tasks, because that doesn't make sense, because you would need something that can handle like character level stuff and phrase level stuff and discourse level stuff. And there's not really an established standard there. So we're probably going to have to do a pipeline for each of these libraries independently. Yao says, small nitpick, a higher resolution would make it easier to read the text. I don't know as I can do that, but I will look into it. The bottleneck here is I'm streaming this from home and my upload speed is very bad. So yeah, but I'll look into it. Okay, we actually want to read it in from, we could do it from a URL. What the hey, let's actually just use the example text from the book. So from the NLTK book, tokenizing from NLTK using example from NLTK book URL. And I will go back and get the URL. Chapter 3. And the book is great. It's a very practical hands-on introduction. It walks you through step by step. It's there's not like a whole lot of conceptual introduction to it. So if you are looking for, I'm gonna zoom out. I will zoom back in, I promise. Get rid of you. And I'm also going to turn on the internet, except I haven't verified my phone yet. So actually we probably can't do this. Or maybe I can do the phone verification right now. Nope, sorry, I'm not gonna type in my phone number. It is fixable. Yeah, so I will do that later. And we will actually just have to read this. So I think I might be able to, can I bet I can just open the file and read it indirectly. You can tell how often I've done this. No, I've done this quite a bit. I just never remember the exact steps because I don't do it in day out every day. Okay, with some label sentences. Oh, that might be a problem. Does this it do have spaces in it. So that's not ideal. And then inside of it, can we get the address for here? We can't. Okay, so I'm actually going to pick a different data set because I don't think this one's going to work out for our needs. Do we have any novels that people have uploaded? Yeah, I've done that. I'm just going to add that. I'm pretty sure. Yeah, there we go. That slug generated correctly. So that should work. And then I'm going to get rid of this. Okay, so I'm going to open a connection to the file, and then I'm going to read it into a text string, and then I'm going to tokenize it, and we're going to see if that works. So with open. And I'm going to give it the file path, which oh, that's what it is. And that's just a text file. And I would just want to read it as file. Oh, you know what? I bet this is supposed to be in quotes. I'm fairly sure. Oh, of course, I should have the quotes correct. Read-only file system. Oh, it's the plus. String object has no attribute decode. All right, so now we have the raw text in. And where was my book? There we go. And it's pretty easy. Tokens equal word underscore tokenize and then the text. And let's see if we get the same output. Oh. I should import the natural language toolkit, huh? It's not gonna work if I don't. So let's do that. And I think it's just, yeah. So I'm importing word tokenize from NLTK, which means that I can just say word tokenize instead of NLTK.word tokenize, and that should work. And it's not a huge data set, so I don't think it's going to take too long. And then let's look at tokens, and they looked at the first 10, so let's do that. Oh, it's not going to work with semicolon, huh? Yes, excellent. And you can see that they have separated the punctuation as their own tokens, which I personally recommend doing. You can learn a lot from punctuation. I've written a couple papers about that. So we should get the same sort of tokens out. Using whatever method. First 10, first 11. First 10. Import NLTK, and I'm just leaving pretty text file tokenize. I'm leaving pretty verbose comments because I want this to be useful for people who are going back and just looking at the thing later. Okay, so that's NLTK. That was pretty easy. Now let's try out Spacey. And NLTK is, when NLTK came on the scene, people weren't using Python as much for NLP. They were mostly using Perl. So if you compare this to trying to do tokenization in Perl, it is like angels singing. It's amazing. It's so much better. And I know some people still teach intro NLP in Perl, which not a choice that I would make. All right, Spacey, Tokenizer example. Yes, please. Oh. I wanted to jump to tokenization. There we go. And you can see it's pretty much the first thing that shows up in the pipeline after sort of the creation of the data itself. And this is the first thing that you do in your, you know, thingadoogle. Copy. This was the first thing that you would do in your workflow. That's what I was looking for. I'm so tired, you guys. And I think we actually have the medium language model installed on the Dockers now by default. So if you want something a little bit bigger, you can get something a little bit bigger. And I am actually going to tokenize this raw text instead. Oop. I actually only want the first 10 words. So if I do, can I just slice a string? Is that a thing? Oh, I have to do it by characters. What if I do 1,000? That's too many. What if I do 100? Yeah, that looks good. Okay. So that way I'm not doing the whole big old text file. So what this is doing is we're importing Spacey. Then we're using a language model, and I'm actually going to run this on another cell just to make sure. Oh, right. It would help if I imported Spacey, huh? Just to make sure that I haven't made some spelling mistakes, because I have been known to make spelling mistakes in the past. Oh yeah, we can use the small then. It should be imported and working fine. I have just misspelled something, and I don't want to go digging around right now. Spacey, which I mentioned up here, provides tokenization based on language models that they also provide as Python packages. You can just download and install the packages as you would any other type of language model, any other type of package. They don't have a whole lot of languages. So English, German, Spanish, Portuguese, French, Italian, and Dutch. Very Indo-European if you're working with like Hindi or Mandarin or Japanese or Sui or whatever. You're going to have a lot of a harder time. And it is MD. Is that what I typed? It might not be what I typed. Anyway, and the ones that are going to have the information on tokenization are going to be the ones that say vocabulary. So the vectors web large only has word vectors in it. It does not have the tokenization information. And the multi-language one only has named entities. So this is like knowing that like Burkina Faso is a place. That's sort of that information. So the thing that is giving us the information that we need to create the tokenization is the fact that we're loading in this NLP object that is a language model, and then we are creating a document from the first 100 characters of our little corpus using that language model. And then in that document, in the creation of the document, we actually do the tokenization. So when you create this document in this line, a lot of stuff just sort of happens behind the scenes very quickly, which is very nice and convenient. And so this should just print us out a bunch of tokens. Yep. And I'm actually going to do the first, let's say the first 50, just so we get kind of more parity. Let's see. The 7. So let's do 51 so we get parity. There we go. So each of the tokens is on a new line. You can tell that these are in slightly different data structures. And, like I said, each tokenizer is going to give you stuff out in a slightly different data structure because it's designed to be plugged into a different pipeline. So let's give this a little guessing in terms of commenting. Ooh, that's not how you spell that. Tokenization using S-P-A-C-Y. Just the C is uppercase. Read in our language model. I think they call this parsed thing a document in their documentation. Yeah, and then there's a more information on how their specific tokenizer works. Create a document from the, I think they call it a doc, from the first 51 characters. And we could do the whole one and that would be fine. It would just print out a lot. Print out all the tokens in our document. Okay, so that is Python. Hello, Carrie. Vamsi asks, is a doc a list? No, I believe it is a specific, what is it? I think, is it types that tells you that's the object kind of a thing in, it's, yes. So the docs are a specific type of object that is specific to the spacey module. Vishnu says, are those spaces after the token moon shadow? Question mark, question mark. It is not the case with NLTK. Yes. Yeah, interesting. So let's take a look at so let's just, oh, we can't do that here. Actually, let's move this up. And then let's print out the first 51 characters. 51. So you can see that this is a new line. And so I think what is happening here is that they use new line as a way to distinguish between tokens, right? So moon shadow, and then a new line because it's a new token, and then a new line because the next token is new line, and then a new line because that's a token. So the reason that there's this big space here is because it is treating this new line in the document as a token. Hello, Danny. Whereas in the NLTK tokenizer, that is not treated as a token. So whether or not it's important to you, it depends. It depends on your downstream task. But when I mentioned earlier that you want to make sure that you say which tokenizer you use, that's why, because they're gonna give you different results. Yeah, and I'm going to examples, NLTK, and spacey. Felipe says, will the full live be available later? I just wake up and miss the beginning. Good morning. Yes, it will be available later. So all of the live streams, pretty much as soon as they're done, get uploaded to Kaggle, and then when I remember, which sometimes is right after the stream is done, I add it to the playlist. And actually, I tried adding a card. So if you mouse over the live stream, there should be a little information bubble in the top right hand corner, and there's a card in there that is a link to the playlist where I put all the live coding videos. Okay, so what I'm gonna do, cue from stream. Their own type of object. Oh, there's a specific name for that, and I don't remember what it is, and I'll just live with it. Okay, so what I'm going to do now, because we are about halfway through, and I want to make sure I have time for questions at the end, is I'm going to commit this, and I'm going to make it public, and then I'm going to go back to the original one that I forked. I'm going to fork a new version, and then we're going to do the same thing in R using Tokenizer and the other thing, which is tidy text. Because you don't need to use tidy text to use Tokenizer, but if you are using tidy text, you will be using Tokenizer. All right, I'll return to editor and make this sucker live. And I'm also going to add my other account as a user, just so it's more visible for folks, because I know my admin account is much easier to find. And I will give myself edit access, unlike I remembered. So if you search for live coding tokenization on Kaggle right now, you should be able to find it. All right, let's go back to our original document, and we should be able to see the fork. I went back, so I should probably reload so that my cookies reset. I don't know, whatever the thing is. Excellent, and that is public. So let's make a second fork that is the R version. Because I've been getting more requests recently to do more R coding, and I'm happy to oblige. I like me some R. Aw, Carrie, I think you're amazing. It'll make me blush. R version. Oh, one sec, I gotta change the language to R. Okay, I know we've got tidy text in here. I'm pretty sure we have Tokenizer in here. And I should probably add my data again, huh? What was it? Paranormal romance titles? Yeah. I think I added this because I wanted to generate new romance titles, and it wasn't really enough to get. You know how like when you get like a generative network, and it just sort of like feels half baked. Like the words are like not quite. That's not exactly right. Like close, especially character level. You're like, some of those are words, some of those are not words. It was that sort of thing. Okay, Tokenizer. Read in our data. Actually, I don't need to do a new cell for this. I can just do a new examples. Tokenizer and tidy text. I think that's the right capitalization for both of them. People tend to get real, oh, it's tokenizers. Whoopsie daisy. People tend to get real creative beans with capitalization in their package naming. Excellent. So this is by, sorry, this is very, very small. This package is by Lincoln Mullen, who is a like comparative history professor, or like comparative politics professor at GMU. So he's coming at this from more of a digital humanities angle, but it's a very solid package. I've used it before and I like it. So, and tokenize words name, Snowball C. Snowball is another R text package that has its own tokenizer. It's not just R, I believe. Yeah, so stemming is something that we will talk about later. That's a secret for the future. It's not a secret. Everybody knows about stemming. Let's see. And now we need to read in the text, and I definitely remember how to do this. Nah, I'm gonna Google it. Read text data into R. I don't want to read to lim. I want to read plain text. I think it's lines. I think it's read. Let's see. Read Fortran. That's not something I've ever had desire to do. Read lines might actually be from the tidyverse. Oh, and then that would actually be underscore. Yeah, I think it's read file raw that I usually use. Input, and then pair romance, and then let's call this romance titles. And let's check out the head to make sure it looks good. Oh, I think I read in the bytes. I don't think I need the bytes. I think I need like the words. Yeah, there we go. Okay, mystery solved. Those were like the underlying byte string and not the actual characters that I'm interested in. And I am going to hide the output of this cell, and then I'm going to look at the first 51 characters again. No, that's not gonna work. Oh my gosh, how is it that you look at just characters now? R print first X characters. That is what I want. Substring. Extract or replace. I do just want to extract to and I want oop, I can't click. Oh, okay, one sec, let me reload. Caesar says this is too girly, bye. Okay. I mean, coding is girly. I learned how to name variables from my mama. Oh. Page is unresponsive. I think I might have printed out this entire data set 51 times. So let's just do a quick little reload. I did learn how to name variables from my mama because I was very bad at spelling as a kid, and I failed a lot of spelling tests. And she'd worked as a computer programmer for years, mainly on Fortran. And she was like, you know what? It doesn't matter how you spell things, as long as you're consistent. And that's advice that I took to heart. Okay, we were doing substring, which I shouldn't need to import because that's in base R. And what if I asked for the first 51? Argument stop is missing with no default. Oop. There we go. Excellent. And I'm just doing the first 51 characters because I want things to be consistent across both language titles. And I don't think this should modify anything in place. So romance title should be exactly the same as it was before this. All right, tokenizers. So I believe I'm gonna have to read in the library. And it is tokenize word. Nope, I don't want the stems. I just want the words. There we go. Tokenize words. So, oh, interesting. So there's an option to remove stop words, which are super common words that occur in all data sets and aren't very informative about the topic of the data set. So in English, things like the, of, and, things you have a lot of. So you can remove tokenizers. You can remove stop words at the same time as you tokenize. It's kind of interesting. I'm not going to choose to do that. Tokenize words, and then just, oh, actually, you know what? I can do the whole text and then just print the first 51 because it's going to be a list. Tokenized data. Oh, sorry. Ezra says, I can barely hear you. You're like a tiny, tiny mouse. You're so quiet. Let me adjust the volume. Thank you for letting me know. I'm also doing that thing where I'm just sort of wandering off with my voice as I'm typing. Is that better? Let me know. I know you're a little bit behind me. Okay. Tokenized. And then if we look at, I believe it was the first 10 that we looked at with our other data. Tokenized. Tokenized data, and it's a list. So in the first item in the list, we want 1 through 10. Let's see if that works. Am I correct about how this is organized? Excellent. Sounds like it's better. Thank you for letting me know, Danny and Ezra. I really appreciate it. Oh, nope. I think I was wrong about how this is organized because it's taking a long time to print out, which means I printed out way more than I wanted. Interesting. So it looks like character tokenization is... Oh, interesting. So it looks like the question becomes a verbal one. Becomes a... The question thus becomes a verbal one again in our knowledge of all those early stages of thought and feeling. Again is the last word in the first word in the second line. Okay, no. So what I was thinking was that each item in the list was going to be a line in the original input, and it looks like that's not the case. Yes, this is too many. What if I used the correct parentheses, huh? Would that work? Yeah, there we go. So this is saying the first item in the list, and then it is saying in that first item, give me the first 10 objects. So again, if we looked back at the other ones in the Python example, Moonshadow had a token after it in the Spacey tokenizer, and it did not in the NLTK tokenizer, and I believe the default for them is the Penn Treebank tokenizer. But if we look here, there is no space here, so it's more similar to the what's it called? The NLTK tokenizer than the Spacey tokenizer. So the library, and then tokenize, look at first 10 tokens. So I suppose the way it's organized that way is so that you can tokenize a bunch of texts at once and have a big list where each item in the list is a separate text. We'll see. We'll see if that works. And you can see that there's lots of different options for tokenizing. So there's individual characters. There's sort of like this sliding window of 3 characters. So if you've ever done any sort of like text augmentation for deep learning, this is sort of a very common technique. And this is a nice way to do this automatically. Not that you should be doing it. Oh, actually, stop words. Okay, so the Penn Treebank tokenizer is an option, but it looks like the default option is something else. And okay, Snowball? No, this is word stemming. It might be from Snowball. I don't know. Question mark. I haven't dug into the source code of this package too much. So the next thing that we want to do, another thing to notice is that these are all lowercase. In our Python code, case was not removed for us, and punctuation was not removed for us. In this case, it is. So remember that in the NLTK tokenizer, we actually had each punctuation mark being a separate token. And in the tokenizer's tokenization, each punctuation mark is actually completely removed, and also everything is made lowercase. So what that means is that whether or not Angels is capitalized, it's always going to be considered a single token, whereas in something that preserves case, you can actually choose to say, actually, I want to count uppercase and lowercase things separately. And that can be useful for words like bank. So I think I mentioned earlier, like bank could be a riverbank or it could be a place. And if you're not doing named entity recognition, whether or not something's capitalized in the middle of a sentence might be a quick way to be like, oh, this is probably the name of a specific bank. And that's, fairly lossy, and I wouldn't necessarily recommend that, but it is an option that you have. So another option that we have is we can use the tidy text package. If you're not familiar with it, it is my usual go-to for doing any sort of NLP work in R, because it is based on the tidyverse, which is a collection of packages based around the idea that data should be tidy. So if it is in a spreadsheet, you should have one observation per row, one variable per column, and one value for each row column combination. So you shouldn't have you can have cells that are empty because you don't have variables in them, but you shouldn't have multiple pieces of information per cell. So you shouldn't have like color coding and underlining, and they both mean something separate. And there's a whole collection of packages built around this that have a sort of a different ecosystem. So if you haven't used them before, I find them very user-friendly and enjoyable to work with. Some people don't like them. That's fine. But I like them. And the tidy text package is one from Julia Silge and David Robinson, which I believe they both started when they were both at Stack Overflow, and David Robinson is now at Data Camp, but Julia's still at Stack Overflow, at least of the last time that I heard her. Anyway, and they're both great, very people that I respect a lot, and it's a super helpful library if you're an R person. And it's built around this idea that tidy text is a table with one token per row. So tokenization is part of the function of putting text into this tidy text format that you can do things with. I will say, It is a little bit slower than something like Spacey. If you have a very big text data set, I maybe wouldn't recommend it. But if you are interested in doing like really beautiful visualizations, I think it's a great choice. So this is a data frame, and this is the tidy text. So we want to put the data into a data frame first and then put it into tidy text, I believe. So the thing that they use for tokenization is this unnest tokens function, saying, well, actually, let's just play around with it rather than just looking at the examples. This is the live coding one, not the live reading one, which I did on Thursday and was super successful. So I think I'm going to do another one next week. Tokenization in the tidy text package happens as you put your data into a tidy text format. So instead of text, I'm actually going to say this is the romance novels. Is that what we called it? Romance title. All right. And I'm actually going to call this, well, I'll keep it textdf, but I'm also going to assign this into a variable so the whole thing isn't printed out. And let's call this tidy romance. Actually, I changed something I shouldn't have. So I think what these arguments do, and I could just look up the documentation, I believe what these arguments do is that this is the name of the first column that has a word in it, and this is the name of the second column that has the information on the text that it's from. But I'm not 100% sure. Let's check out the documentation, actually. No documentation for unnest tokens in specified packages and libraries. Do I have to specify that it is in tidy text? Let's see. Tidy text. There we go. Be bigger. Split a column into tokens using the Tokenizer package. Okay, well, if I'm in it, I'm moving it, as it turns out, so it's going to be hard to scroll down. There we go. Tibble is a data frame that we're putting into it. We don't need to specify it here in the unnest tokens argument because this pipe says whatever is to the left of me, take that and make it the first argument in the next function that I'm using. So if I wanted to take this and put it into something else, I could do another pipe after it and then another pipe after it. So it's sort of like a sequential top to bottom pipeline deal. So I don't need to specify that. Output here is output column to created as a string or symbol, and text is the input columns that get split as a string or symbol. So text, I believe, is going to be from our input data frame, and then the word is going to be the name of the column in the output, I believe. And then tokens, the units for tokenizing, which is not specified here in this example. Built-in option are words, default, characters, character shingle, so that's sort of like the sliding window. N-gram, skip-gram, sentences, lines, paragraphs, regex, tweets, tokenization by word that preserves usernames, hashtags, and URLs. So this is all using the Tokenizer's package. And by default, if you remember, it removes punctuation, which is important for things like URLs. And then PTB, which is the Penn Treebank, which is the one that the original NLTK thing that we were looking at used. So what we're going to need to do is we're going to need to turn our data set, our romance titles, into a data frame. I'm going to get rid of this. Is it? No, I think it's as underscore data frame. I think. Yeah, as underscore data underscore frame. And that should turn it into a tibble, which is the tidy version of a table rather than a table. And I believe we called it romance titles, if that is correct. And I'm actually going to do this. I'm going to try it out in a separate cell because I think I might have done it bad. All right, and then head of romance title. Oh, I assigned it to its own name. It is value. And I printed out the whole thing. So we're gonna take a moment for our kernel to chug away on this. There we go. I don't know, something about printing out a lot of text seems to be a problem for Jupyter. I think it's a Jupyter thing. I don't know, shrug. I just try not to do it. Okay, so we should be able to do that. And then this was the output was word, so that's what it's going to be called. And the input in our example was text. And I believe here it's going to be value. And I'm going to call this tidy romance, which is where you completely avoid sprinkling rose petals on stuff because that gets everywhere. All right. Oh, yeah, that would do it. So I forgot to change the name of the input data frame from the one that was provided in the example. And then if we look at the head of tidy romance, we should see a very beautiful tokenized list. So this is not a list, I'm sorry. We should see a data frame that is one column, so a vector, because everything in R is a vector. But because it's a data frame, it has additional information such as header, and the column is called word because that's what we specified here. And if we called it instead something random without a space in it, that would be the name of our column. And as you can see, it's fairly fast. That's a pretty nice example. So let's us actually call this word. Let's call this something good instead of something awful. And then I actually don't want just the head. I want the first 10 rows. So 1 through 10, and then all of the columns, even though there's only one. All right. And that is the whole thing. We get rid of all of these extra cells we put down here at the bottom. I will comment this up and then make it public, and then I will have time to answer your questions. So if you have questions, ask them in chat now so I can get to them by the time I'm done typing and then we've all catched up with each other and we're not doing the weird time travel thing. So convert our text into a data frame. Convert our data frame into a tidy text object, which includes tokenization. Check out the first 10 tokens. All right. And I am going to commit this. There we go. Sorry, you have to, if you are in here, you have to click out to create the commit, and then it's going to run from top to bottom, which hopefully shouldn't take too long unless I've done something dumb and like done some horrible matrix factorization I don't remember doing. It's not that bad with matrix factorization, actually. The recent R core updates have been very solid. And I'm going to add myself as a collaborator. Myself. And I see that Vishnu has a question that I will absolutely get to. Oop. And I do want to give myself edit access and also want to make it public so you guys can check that out. And we should now be able to go to here and see it, and anybody should be able to see it. So if I search for live coding tokenization R, I should see my nice example, and I do. Okay, so Vishnu's questions were any specific reasons for using NLTK over Spacey? Yes, so it really depends on your needs and your use case. So I am a big fan of Spacey. If you guys didn't know, by the way, we're currently holding a competition about where if you make a Spacey a kernel that uses Spacey, you have an opportunity to win a copy of Prodigy, which is an annotation tool that's really nice. So it's a perpetual license. And we just announced the first round of winners. We're going to announce the second round of winners next week. So please feel free to make a kernel if you're interested. Spacey is very fast. Spacey is really good for putting things into production. It is designed for industry. It is designed for practitioners. It's very well optimized. Actually, I think they've got some benchmarking right here. So, and you can see they've got word vectors integrated, so you don't have to like download your own and futz with those. I mean, you don't have to download them if you're working on Kaggle because we got word vectors anyway. It does co-reference resolution, it does entity recognition, it does most of the things that you'd want to do in any in any what am I looking for? NLP process. The biggest problems, the biggest reasons that I would want to use NLTK over Spacey, I would say I have not used Syntax Connect, I have not used Core NLP. I know some people like Core NLP. I don't like Java, so I don't use it. Is that it doesn't support a lot of languages. I think we were looking at it and it supports like 5 or 6. I think there was a list in here somewhere that we looked at earlier. And they're all Indo-European. So that's, if you're not working on one of those languages, you can't use Spacey. It's just not going to be helpful. And the other big thing is that it's less flexible. So if you're doing tokenization, you get their base tokenization that they use. I think they might have like maybe a couple different options, but NLTK is very, very, very flexible. So it's like it's designed for researchers, so it can really be used for very specialized use cases, and you can really drill down into specific questions. So it's, I guess the best analogy would be like driving stick shift or manual as opposed to driving automatic. If you don't know as much about what's under the hood, manual might be better for you. But if you're really knowledgeable about what's going on and you sort of like have the skills already, then stick shift can help you like do things, that you wouldn't be able to do otherwise. If that makes sense. Vishnu asks, does this demo count for this composition? I mean, I can't win Kaggle prizes, so no, not for me. I think they would want to see something else, so I think we announced the winner, so I can show you guys an example. Let me get to Kaggle Twitter. So we can see the winner of this week's award. That was Narant. And this is a analysis of the Hitchhiker's Guide to the Galaxy. And there's several things that go into here. So named entity recognition, part of speech tagging, doing some annotation, and then some question and answer generation. So that's a lot, but it's a really nice kernel, and obviously won our competition this week. So this one won, I believe, the $500 prize rather than the just the copy of the annotation software, which is very nice annotation software. Yeah, we're, I would bring your A game. Let me put it that way. Yeah, and there was something else I was saying and I have immediately forgotten what it was. Cesar says, what? No Java? Bye. Yeah, I don't like Java. Partly because I've been getting more into functional programming recently, and Java is just like super duper object oriented, and also because I always forget a gosh darn semicolon somewhere, and even though I know I'm gonna do it, I still do it, and it's a pain in the butt. So like nothing against Java in particular, it's just not as fun for me. shrug. My husband likes it, so. Although he's been really hot on Kotlin lately, which I have not played around with that much. And apparently some people are doing deep learning in, which surprises me. I don't know. Or maybe, no, never mind. It was Go. It was Go that people were doing deep learning in that was surprising to me. I mean, I wouldn't, but if you're already using Go, maybe it's helpful. Oh, I'm not a Go person. Cesar says there's functional programming in Java too. Bye. Okay. I'm probably not going to use it. It's also not one of the languages that we support. So if I were going to learn another language right now, it would be Julia, probably. All right. So that is 5 o'clock. About time for me to wrap up. I will be out of town next Friday. So I'm not going to do this stream. But I'm thinking of doing my paper reading stream maybe on Monday mornings. I haven't decided on the time for that just yet. So I am planning on doing a paper stream next week at some point. I will announce when. Definitely not Wednesday, Thursday, or Friday because I'm traveling. But when it happens, I will tweet about it and it'll be on this channel. So if you're subscribed, I think you'll get a notification. I think. Yeah. All right. Well, thanks for coming to hang out with me, guys. I hope you guys have a good weekend if you don't work on the weekend. And a good weekend if you do work on the weekend. Everybody gets a good weekend. And I will talk to you later. And we will read a paper together. Bye-bye.